Hello, everyone, and welcome. I'm Adrien Sinabria, host of the Enterprise Security Weekly podcast and principal researcher at the Defenders Initiative. Welcome to this webcast sponsored by Fastly. I have three guests with me today. Gary Harrison, staff detection engineer at Fastly. How are you doing, Gary?
I'm doing great. How are you?
Doing good. Looking forward to today's conversation. Also with us, we have Marcus Young, Senior Security Engineer, Detection Engineering at Fastly. How are you doing, Marcus?
Not too bad.
And finally, Simran Khalsa, Staff Security Researcher at Fastly. Simran, I forgot to ask you how to say your name. I hope I got that close. How are you doing?
You got it. You did well. Thanks. I'm doing well. Thanks for asking.
Yeah, with the last name of Sinabria, I try and make a point of saying people's names correctly because I've heard plenty of interesting variations on my name over the years. In fact, that's you. Well. If you've ever seen me online and wondered why I go by the handle Zawaba, that is the worst misspelling I've ever seen of my last name. So that's where that came from. I just owned it. All right, today we're talking about detection as code and how it can enable more effective security operations. And just a quick tutorial on this platform. You'll see some blue buttons down at the bottom of your screen. One of them is just a general chat. Anyone, let's see, I'll go ahead and send something there so you can see it there. And looks like Jerry did as well. So you can ask questions there. You can chat with other people that are here attending the webinar. But there's also a Q&A button, so you can click that. You can submit a question in the Q&A button. I'll be checking both places as we go. Feel free to ask questions as we go along, and I will periodically check that and pull in the questions as it makes sense. And then that final blue button down there, the last one, or first one from the right, is the handouts button, and there are a few links there to some of the blog posts that we're talking about that we're kind of were the ideation that resulted in this webinar. So you can check out those if you want some more details. If you want some links to some of the things that we're talking about, check out the links under the handouts button there. All right. So without further ado, let's jump into it and just laying some foundation here. When we talk about detection as code and kind of the context for this, with Fastly sponsoring and everything, the focus is web application firewalls, though the conversation need not be limited to that. As detection engineers, I'm sure you're working on stuff beyond that scope in your jobs, and yeah, specifically detections and defenses and the relationship between the two. So the first question for the audience. I'd like to get a feel for how many folks we have in the audience. We don't really have a polling function here, but if you could chime in the chat, how many of you are detection engineers, or you're in a role where you're having to build detections or manage a WAF, one of those two things. All right. And coming to you first, Marcus, my first question for the panel of folks here. Speaking of detections and defenses, how closely related are these two? And, I imagine there has to be a lot of good communication if it's not the same person building both, right?
I would say, yeah. I don't necessarily call them one-to-one. They're definitely related in a lot of ways. For example, you may have detections that don't work. So if you tie those one-to-one, then your defenses are kind of off, right? You have this false sense of security. You think you're protected where you're really not because you're relying on these data points that aren't working as expected or don't exist. But also, detections may not be a defense, right? It may just be notables or information for other teams, other parts of the organization. And it may just be a way to surface information. It may not actually be to defend, just to kind of give you information about the current state of things. And then also, I think the most important ones is that a lot of vendors, a lot of tools, a lot of tech comes with out-of-the-box detections, and it's important to remember that they may not work, right? Your data may be slightly different, it may be out of date, there could be a million other things, and you may end up having to tune them.
Yeah, I think you're being a little kind there. It's I can't speak from experience with WAFs, but having built many SIMs over my 20-plus year career, I can't recall a single out-of-the-box detection that I kept unmodified. All right. Yeah. So, is it that, so the relationship between these two, one of the things I'm wondering here, because it's been a while since I've been in the thick of things here, does some of those detections kind of inform the actual defenses that you put in place? Like you look at enough detections and you think, you know what, we shouldn't even be allowing this. Like this should just be blocked, rather than us responding every time it happens.
I think so, and I think later on Gary's going to get into a lot of that with like false positives and true positives and things like that. But I think a lot of times it's really just to be informative. When I try to go the other way around, I don't try to start from what detections we have. I kind of find that to be a disservice because you may have a ton
Mm-hmm.
of detections. They may not work. They may not be exactly
Right.
what you expect. But you don't. I don't think you want to start from there. I think you want to try to build up what gaps you have and what gaps are most important to you. You can't really. I've always had this opinion that you can't really protect unless you know what you're protecting. And so I
Yeah.
think it's more important to go from the other way, from the defense up, talking to other teams, kind of getting like stakeholders and saying like, what's most valuable to you? And like, what risk does that
Mm.
present to the company or your org or your team? Or maybe you can kind of go a million different ways. But I think not only is it a little bit collaborative in that way, you get to learn a little bit about what they find important, which means that it's probably important to that part of the org. And you get to build up kind of like what I call like the crown jewels, right? Like that one team may valued some data more than others. Some may consider risks because they don't even have the data, and so you can kind of use that to inform. Okay, we're missing a huge gap here, and we can't even build anything off of it because it just doesn't exist. But it is really important, that kind of thing.
Yeah, and that's kind of as you alluded to. That's what I wanted to come to Gary with here. Is I think sometimes every organization is different. Each application is going to be different. It really tough from the vendor's perspective to put together stuff out of the box that's exactly what you need, right? So you're going to have to tailor some of that stuff. But Gary, how do you come to it? Is it better to start with a blank slate and gather those requirements, have those interviews, understand the application, and then come back and say, okay, maybe 40% of these detections are along the lines of what we think we need. They can stay. The rest we're going to have to build custom, or do you just scrap everything and start from scratch? Like where do the ideas for those detections come from, and how do you get started?
Yeah, I mean, so as anytime I start, with a new team, the thing I like to do is find the person who's been around for the longest, buy them a coffee or a beer, and watch the skeletons fall out of the closet. Um, and that's a really great place to start for your internal ideas. But I think, kind of more broadly speaking, you can find ideas for detections, kind of looking at your internal documentation. If you've had risk assessments done. So one thing that we look at pretty heavily is like our risk registry. We're in touch with our security architects, and we make sure that we understand where those areas lie, so that we can apply detective controls to those areas. So having kind of like Mark had said, having strong relationships with those internal teams is useful. But also keeping an eye on externally derived information. So this is, reading your threat logs, reading your threat intel, understanding, current attacker TTPs. But I think the trick with that is being able to pivot that into the, to answer the so what does it mean to us? So if you haven't done that initial legwork where you kind of mapped out your own environment, you've identified some of your own risk areas, even your own technologies. Some of that may be irrelevant to you, and that's where I think the gotcha on a lot of the out of the box vendor rules come from, is they're either really specific to a particular threat, a particular TTP, or even a particular technology that you just don't use within your landscape, or they're so general as to just be false positive, like noise generators. So there's a potential for risk there. That's kind of how I'd like to approach it.
And I imagine you've got stuff on both ends of that, right? Like maybe you look at stuff and I imagine you track these kinds of things and you're like, this hasn't fired in 3 months, and maybe it's good that it hasn't fired in 3 months, because if it did, that would mean something really bad. Do you sit there and you wonder, okay, is this just broke, or is it just that, really bad stuff hasn't happened?
Yeah, I mean, the false negative risk is always the sneaky one, right? Because if it hasn't fired in 5 months, it's like great, this is a great detection, but maybe not. So one thing you can do is look at past incidents. I actually think that's a really great place for feedback loops. I absolutely love establishing feedback loops. Like anytime you have an incident, even if it's minor, figuring out where within the kind of attack lifecycle this was caught, and how could we have caught it earlier? Did it bypass a detection that we have in place that we thought would catch this particular technique? If it did, that's a pretty good indicator that that something was missed. And then this is a little bit more, I think, more of an advanced concept, but there's like attack simulation types of activities that you can take on to do some sort
or
of
a pen test, right?
For your detections, or pen test. Yeah, pen test would be good. I mean, ideally, you'll be able to do continuous validation. But absent that, absolutely use what you have available to you, and basically do your best to, when something doesn't fire for 5 months, review it. I mean, when we're looking at our keeping our detections healthy, that's one thing we do is like, hey, for quiet alerts, like we'll still raise tickets for that. We'll still make sure that those get brought up to our attention so that we can validate that, hey, this is still good.
Yeah, one of the things that always kind of bugged me, and I may have a sneeze coming here, so I may have to pause as I make the statement. But when pen testers come in, they're like, "Yeah, we need you to whitelist me in your WAF before." I'm like, but then the WAF doesn't get tested, and that's one of the things we want to test with this pen test, right? I guess it depends on the style of pen test, right? You've got like white box, black box, crystal box, all that kind of stuff, But yeah, that was something that always seemed odd to me, is like, take down your defenses so I can test your defenses. Not sure that makes a whole lot of sense.
That's kind of defeating of the purpose for sure. You want to be able to use things like pen tests to gather the information that you can. So actually that's where I like, and I'm going to use an industry buzzword, so I apologize. That's where I like purple team assessments a lot. Where you're working hand in hand, your defenders are working hand in hand with the pen testers. So that you can understand the way that they're moving and how an attacker might actually do it without the obvious risk of an actual attacker doing it.
Right. And Marcus, coming back to you, just talking about the process of building some of these detections. There's kind of I don't know how famous it is. I talk about it a lot. If you've heard me on my podcast or talked to me, you've probably heard me mention Equifax a whole lot, just because there's a lot of lessons that we were able to learn from that. But one of them was the emerging threats team building a snort rule, handing off to the ops team. They deploy the rule. Neither team thought to test it, right? It just wasn't part of their process or maybe it was just because it was an urgent thing and they pushed it through too quick and they forgot to do that. But either way, it didn't seem like they had a good process, engineering process. There was no QA step there, and the snort rule didn't work, and they ended up getting hacked and didn't know about it for a couple months. Until a couple months in. So, maybe walk us through a little bit, like what is your process for, you've decided, okay, we need this detection. How does it get to production from there?
So to keep things at a high level, because it's very dependent on your maturity, your tech stack. But for the most part, so I come from like a software engineering background. So I try to treat everything with the same like software development lifecycle of, you start with a problem, right? I mentioned earlier, starting with like what you want to do, so that you can kind of measure along the way. And also that way you should have some data to start with, right? If you're looking to build a detection, you should have a reason. We call it the hypothesis in other ways, but like you should have a reason and you should have some way of building that off, right? The data points, maybe you're missing data, and part of that is building up the prereqs. Like if we want to build this, we have to go and enable this data or hydrate this data. But that's where I start. And then I think it's important to, from that point, kind of continuously move it along the way. So once you know that you have some data, you can test it, make sure that it is going to fire the way that you think it is. I'm not a big fan personally of fence throwing, what you would mention, right? Like one team handed it off to another and expected it to work, and then they found out later that it didn't. So kind of taking that data-driven model to build this process together. It should be everybody's job to make sure that it's out and working. And I think that is important to say in different ways, right? Like one team just makes sure the data is flowing. One team is there to make sure that the bits and pieces work. But I think everybody's job there is to kind of move it through this cycle and continuously test it. And I think that's the hardest one and one of the most mature things that you can do. And I usually kind of say that not everybody is there or will get there anytime soon. And then I think the most important thing is creating a feedback loop, right? Once it's out, it's not done. There may be positives, there may be false positives, it may not work. It's going to get updated at some point, just like any piece of code. And I think it's important to take that mindset and just say, it's deployed and it has a status. And so kind of moving it back and forth across the status in this feedback loop of saying, okay, we need to update it. We had an incident and it looked like it didn't catch this edge case. Or, we're in the middle of something else and we're realizing that like it could be tuned better if we just added more data to this other system. And continuously like moving it back and forth and back and forth. And then like you had said earlier, kind of purging them, I think is also kind of important. Things may change over the time, systems change, systems get dropped. And it's important to review these, I think, regularly on some sort of cadence, right? Like to go back and just say, has it ever fired? Is that good or bad? Is it broken or is it working really well? Or do we just need to get rid of it, right? Does it even make sense anymore? Do we have that system that we need to protect? Or we wrote this because we didn't have these controls or guardrails in place, and now that's a much more mature system. Maybe we can make this fire a little bit less or just get rid of it, right? Maybe we have more maturity somewhere else we can lean on. So that's kind of like my long-winded answer of I don't really care how you do it, but I think it's important to start with data, always test, and continuously like review and put it back through the loop.
And I'm kind of curious in an environment with a very active code base, with an application that's receiving a lot of updates, agile DevOps type of environment. How often, like ideally, you'd hopefully find out that you need to update a detection to keep it working. Like say something, a breaking change happened in the application that caused a break in the detection. Like, are you finding out after the fact, or do you have some way to find out before it goes to production that you need to update that detection? And I imagine there's also a process maybe on the attack side that like I remember back when Log4j or Log4Shell was a thing. Like people are updating their WAF rules like every 30 minutes to keep up with all the new evasions that were popping up.
I think it's a little bit of both, right? I think you're never going to be perfect. The larger scale the company, the larger scale the data, things are going to move without you. You're never going to be fast. The detection team is never going to be as big as the engineering org, and you can't be a slowdown in the process. And unfortunately, I think the bigger the company, it kind of exaggerates itself. But you're always going to be behind the curve. I think it's important to build those bridges early. I talked about kind of using what other teams use and building yourself in and involving other teams. I think that helps the most because you become privy to these conversations when they want to optimize, and like maybe they're going to remove the data from Splunk because it's too expensive and they're going to move it to something like Loki or BigQuery or an S3 bucket as like Parquet files or something like that. Those conversations and that work is going to happen, right? It's a business move. It's an org move. It may even be a maturity move on those other teams. And it's important as a security org to try to be a part of those conversations and keep up with it as best as you can. But because of that, you're always going to be behind. And I think it's just a state of life. I think that's always been the case for anything that's data related, whether it's security or not.
Yeah, gotcha. I just wanted to add to that a little bit because I think that's a great point. Being part of those conversations and embedding yourself within the broader engineering organization is very important. But I think the question was framed in a kind of specific to the detection level. Like to me, this is where it's really important to have like within your SIEM, your detection engine, or whatever you're using, data quality monitoring at the ingest level, right? So if you have a data source that goes dry in Splunk, for instance. Generate an alert like, hey, we haven't seen data for a certain amount of time, or it's
almost like a negative rule, right? Like it's so easy for some of those things to go unseen.
Yeah, absolutely.
Sorry, I interrupted. I didn't know if you were done with your.
Oh, nope. That was my point. Nope, I'm good. Thanks.
Yeah, that was one of my big frustrations. Surely they've done it by today, but even 10 years ago, the last time I built a SIEM on the enterprise side, I was just kind of shocked that there was no built-in rule to let you know when your firewall logs would go from 1 million a day to 0, right? Like I would think that would be a red flag, and there'd be something built in to just say, hey, this source of logs that where you get 1.1 million events every day just went from 1.1 million to 0, but every time I've built one, I've had to kind of build that in myself. So I imagine if you've got multiple different data sources here, that's something you have to do to some extent here as well, right?
Yep, absolutely.
So Simran, I want to pull you into the conversation here. Also just before we leave, just talking about the process of building, testing, evaluating continuously these different detections. Is it typical that you have someone with like an offensive mindset, or with pen testing experience, something like that, to inject the different attacks to test these rules? And also want to kind of bring WAF Simulator into the conversation here, because that's the tool that you guys built to kind of streamline a lot of that testing work as well, right?
Yeah, no, absolutely. Ideally, it would be great to have somebody, that's more of an offensive mindset, but it doesn't necessarily mean that you have to, right? I think anybody with the mind to ask questions about does this thing work as it should is good enough, if you don't have anybody that's, an expert. But like, talking about the full life cycle in general, we can, break it down from, the kind of ground truth is like just having a proof of concept is kind of the most basic requirement for developing a detection, right? It's a working example of the exploit. I think it provides kind of the details and the pattern that you're trying to detect, and kind of without a POC, you're guessing. So, and I think once you have that initial POC, then you don't stop there, right? Then that's when you think with the offensive mindset. You think about, how would someone try to evade this detection? Could they encode it differently? What happens if you change maybe the casing or the spacing? Like, can you inject this attack payload through different parameters to maybe achieve the same outcome? So, and what that does is it helps you establish all the different possible variants of that specific attack. But I think just as important is writing the false positive test cases, which we kind of touched on a little bit already. But it's essentially a detection rule that, if your detection rule is signaling on the wrong pattern, it can actually create like alert fatigue, and it can lead teams to pretty much ignore or just disable the rule completely. So I think like with every detection rule, you should write a test of false positive test cases that can superficially resemble an attack, and it will help you validate that your rule isn't too like overly broad, right? And so I can give an example of this, like if you're writing a rule for, to detect SQL injection attempts, and maybe you're looking for the keywords union select, right? Your false positive test cases, they might include maybe product descriptions, blog posts, or even debug logs that could use similar terms, but in a non-malicious context, right? And so, and then ideally, I think once you have your true positive and your false positive test cases, then you need to run those simulations, like using a WAF simulator or whatever the tooling, the security tooling that you're using provides, right? So it kind of, if you break this down in a development life cycle, right? I think first it's like, your payload sourcing, or developing your proof of concept. Then you're doing some type of pattern extraction. Then you do the rule creation. Then you do some evasion testing, and then the simulation and the refinement, and then the deployment of that. And so that's kind of every step feeds into the next.
Yeah, I like that. That's I think that's a huge tip right there. Not just throwing real attacks at it, right? Because like a lot of these breach and attack simulation tools that I've seen, both open source and commercial, really just focus on throwing real stuff at it. Stuff that look like things attackers would actually do. But you're also talking about throwing things at it that might kind of look like attacks but aren't, and you don't want to trigger on, right? Like that's the thing. I don't see as many people doing that, and I haven't heard that as advice here before.
Yeah, it's absolutely something that we kind of like, at least at Fastly, we kind of pride ourselves on when we're writing detections, and we write detections more for the product side for our security products. And, we kind of pride ourselves on high efficacy rate. And so we like to run through, like, have a low false positive rate, and so our customers can feel like they have higher confidence at actually like blocking versus just turning the thing on so they can, do log analysis later. They can actually use the product as it's intended. So yeah, absolutely.
Yeah, that's great. That's huge. So before we move on to talking about detection as code, just if any of you have any kind of pitfalls to share, like if you had an intern or a junior person, like what are some of the mistakes you would expect them to make or that you've seen people make, or that you've made yourself, that you would kind of steer people away from? Just any of you can chime in if you've got anything.
Yeah, I have a couple of thoughts on that. I mean, I think we're really looking for like when people are writing detections, it's kind of, I would say, knee jerk to try to write something that's like, the one detection to rule them all, right? Like let me catch all the bad things with this, this one super query. And that's generally a recipe for for false positives. It's a recipe for false negatives even. You really can't, if you're not specific with what you're trying to detect, really you're just hunting at that point. So I would say like, hey, casting a wide net's great if you're writing a hunting rule, but this is, it's oftentimes not. So Mark had mentioned earlier that when we create detections, we start with a hypothesis. If we start with a hypothesis, that's kind of our our roadmap essentially. Like, so this is what we want to detect. Here's why. Here's how it affects us. And only after we can define that concretely do we start writing the detection. So making sure that you kind of, right size it, I suppose, in that way.
So maybe you think you're writing one rule, but once you do the analysis, you realize, oh, this needs to be 3, something like that.
Yep. Yeah, exactly. Like if you can't tell me the specific behavior that detection should be detecting, you need to go back to the drawing board and revise that. I think conversely, casting too narrow of a net, too small of a net, being a little bit too focused. So like if you're writing a detection for like, and I always refer back to the pyramid of pain of threat intelligence. So at the bottom you have like your MD5 hashes, and then your IP addresses. And when we're writing detections, we always try to write behavioral detections. They're the longest lived. They're the most difficult for the attackers to change. That's not to say that IPs, MD5s, etc., aren't useful. They are for context. They are maybe in short-lived detections, but kind of understanding where within that framework the detection you're proposing lives is important, so that you can set things like manual review time or possibly manual age off. Like for the case of like MD5 or IP address, like you probably aren't going to want that in your sim for 3 years.
Right. Yeah. IP addresses change, especially if it's dynamic coming from AWS, something like that. Yeah. I've heard those stories. Any others before we move on to detection as code? Any other pitfalls or advice there? All right, we can always chime in with it later. Simran, coming to you to maybe just give us a general overview of the concept behind detection as code.
Yeah, no, absolutely. I think we touched on it a little bit already, but detection as code, it's just all about testing your detection logic like any other form of code. It's version controlled, it's peer reviewed, and it's tested. So instead of editing rules or detections directly in some interface of the tool, you manage them in code repositories with pull requests, CI/CD checks, automated testing, and so it's reproducible, it's scalable, and you can audit your detections. And
gotcha.
Feel free if there's anything you guys want to add to that.
Yeah, I mean, there's a ton of add-on questions here. Like obviously, there's going to be some overhead with that, right? Like you've got to figure out, are we going to roll our own thing here? Are we going to use the same stack as the engineers we're working with, right? Like you've got to make that decision as well here, right? Just a tooling piece.
Yeah, no, absolutely. So yeah, it's just I mean, and everything is different, right? I think in terms of where you're writing the detections, it can depend, on what tooling you're using. Like if you're using a SIM, but if you're using another tool like a WAF to maybe, protect your application code. So there's different detection logic that you would write in both between log analysis and then actual detections, right? And so ideally you would do it in both places, at the WAF layer to maybe stop traffic early, but then you have the same principles that apply at the SIM for log analysis. So it really just depends on the architecture, but wherever you write your detection rules, detection as code makes life easier for sure.
Yeah, it makes sense if you're doing detection at different layers, right? Like if, maybe, the amount of time it takes to get to the SIM for a SIM detection to fire is just too long. If that's 5-10 minutes, something like that, maybe that's enough time that you want to have that in a different layer, have that directly on the WAF. So Marcus, coming to you, like where is that cutoff point? Where do you get where you're like, okay, we got to start, like this has become untenable. Like we need an automated process for this. We need to get into detection as code, and where maybe it's just not worth the extra effort to set all that up. Like obviously, it's going to be different for different environments, different folks. But do you think of that in terms of, okay, now there's 5 people on the team, like as a number of people involved to keep everybody on the same page? Or is it a number of detections? Is that where the threshold is looked at? How do you think about that?
So the way that I tend to do a lot of this stuff, like the DevOps and anything as code, whether it's infrastructure as code, detection as code, is I try to start with toil, and I go from like the developer experience kind of model is like, where's the toil at? Is it that we don't have enough people? Because I'm not in a position to solve that, but maybe we can take the pain points from somewhere else. But I think for me, it's always starting with what is the problem we're trying to solve? What is causing the slowdown? I don't think it's always going to be the number of detections. I think it's great if you have a lot, but that doesn't necessarily mean that it's bad. Maybe that process is working for the amount of people or the amount of detections that you have. I think for me, it's really starting from usually like lack of context. I think that's usually the first thing that gets lost, right? You have a bunch of detections, maybe you even just have a few, but teams change, there's layoffs, people come and go, and I think a lot of that context gets lost with it over time. And that's what's great about source control, right? You have tickets, or you have conversations, you have pull requests, you have change sets, you have change, like all the deltas, and I think that keeps this record of everything that you want, right? Almost, it's a ledger of all the changes, what you're tuning, why you're tuning it. And that's usually where I start, right? That's the first thing that you lose when people are gone or things move. You have these detections. You're like, why did we write this? Or you migrate your SIM and all of the metadata is lost. So you don't even know who wrote it anymore, or when, or why, or what. Was it because of an incident? Was it because an executive wanted it, or a product owner wanted it? I would say that's almost always where I've seen it kind of get started, is trying to build up this model of like, why did we do this, and how do we know it's working?
Yeah. I've got a friend who started up a security at a fintech, and he just decided, you know what, even the lawyers, like our privacy policy, terms and conditions, like all that, like I'm going to teach them Git. All that stuff is going to get stored in a repo somewhere, and lawyers are gonna have to do policy and legal stuff as code now. Yeah, everybody checks something in. So I can imagine some people joining an organization. Yeah, you're a technical writer. Here's how to use Git. But yeah, I mean, this was a company they were starting up from scratch, so it was kind of like, we can make it up as we go here. Like we can do stuff that you could never do jumping into, a 100-year-old bank or something like that. You just wouldn't get away with it there. So with these pipelines, like I imagine once you do have detection as code, like what are some of the things, maybe coming to you, Gary, that you could do that you just couldn't do if you're managing everything manually? Like, what are some of the advantages of that?
Yeah, I mean, so I think, other than, the ability to kind of, go through past versions, kind of understand the history better, it just makes applying automation a lot easier. It makes orchestrating and applying, just management of detections a lot easier. I think about trying to update, let's say 100, let's say outputs for a Splunk detection. And, maybe we have to change, a webhook output. Having to click into 100 different detections in the UI is a major pain. But, with everything as code, if we define the output as, within code, we can, refactor that, no problem. Simple, Command F, right? And then, again, being able to apply that automation, we start monitoring for the health of your detection. We set maybe a true positive to false positive ratio that we're looking at. And when we breach threshold, we can automatically say, okay, hey, this one, middle of the night, 3 a.m. Went to like 70%, like just started going nuts, right? You have 1,000 alerts on this particular detection. We're monitoring that. Let's just kill it. There's absolutely no way that this is valid, or if it is, our team's very much aware of the fact that there's this is fired because there's 1,000 of them, so we can go ahead and suppress that for the time being. Or at least on the alerting side. So you can get really granular with the way that you manage your detections, and then even like automatically raising tickets for your detection engineering team if that's not the same as your responding team, to go back and refine. So I think in a sentence it helps you define feedback loops a lot more easily.
Yeah, and I think that it seems like a big thing to me here. Like I love the false positive testing, and it seems like one of the things you're going to do here, like especially if everything's automated to this level, like do you find yourself building a dashboard to look at some of these metrics? Like this hasn't fired in 5 months, this fired 5,000 times in the last minute. Is that something you're dashboarding, or like a report runs on it every now and then? Like once you get up to hundreds of detections across not just a WAF but other things, like how do you manage all that as a whole, from like a quality assurance, or deciding what to get rid of, what needs to get built situation?
Yeah, I mean, dashboards help. Through your SIM, typically you can have a dashboard that fires off an alert when a threshold breaches. I guess it's kind of a meta detection in that case. Automation helps. Monitoring, like let's say you're feeding your detections as they fire into a SOAR. You can have your SOAR, monitor for previous historical firings of that. You could probably get that from your case manager if it's not directly tied to your SOAR. So there's a lot of different places you can look. And I think the last place would be as during the detection development process itself, kind of as Simran had mentioned, identifying the false positives that you want to look for, and kind of getting started at the earliest possible stages of the detection development to identify those kinds of potential problems.
Yeah. And then, how closely are you working? We talked about early on, like how do you figure out what detections to build? Are you regularly meeting and working with the folks developing the application that you're building these detections for? How often do you talk to them? And is that something that even helps? Like, I don't know if they get anything out of that conversation with you, or it's all one way, like you trying to understand, what's coming up on a roadmap maybe. Does it make sense to have regular conversations with the AppSec, or not the AppSec, but with the application folks?
It can be useful. I think what I like to see the most is having a reason for a meeting. I absolutely hate having to go into a meeting and kind of all staring at each other like, why are we here? So being able to identify the inputs and outputs of like how that relationship works is important. So like for our Simran's team, they publish a lot of really great intelligence reporting. So that's something that I'm always eager to take a look at. For me, I think our most fruitful conversations happen within like the security architects, those who manage kind of our risk, our vulnerability teams. And we do meet at currently a monthly cadence, but we have ways of, we have like detection idea intakes. So it's really about developing process as well as, formal meetings to make sure that, when somebody wants to raise their hand and say, hey, I think I got a problem, that they're able to put that in front of us.
Gotcha. Another question for the audience here. Any of you out there already using some sort of detection as code in your environment? Just curious to find out, like, is this, like in your minds, is this just something that happens at Fastly and Netflix and, like SaaS and cloud first organizations, or is this happening in other organizations as well at this point? I like to just have a general idea of like how quickly some of these ideas are traveling. I still regularly have advisory calls with folks where if I told you like the context of the call, you would think this call occurred in the early 2000s, right? Like, so not everybody's quite as not everybody's WAF simulator level, right? And integrating that into a pipeline. So yeah, let's jump into so maybe one last question coming back to you, Simran, here. Maybe some more details on WAF Simulator before we get to recommendations for the audience and takeaways. How do you see people, or how do you recommend people integrate that into that CI/CD pipeline? Because in the last webcast we did, you gave a great demo, just kind of showing how you would use it manually when building detections and testing detections. But eventually at some point, like we were talking about, you've got hundreds of detections. You want to automate a lot of this stuff, right? So what does that look like from an infrastructure perspective or process?
Yeah, so yeah, you're right. So it's available kind of both through the console, so you can quickly spot check detections, or it's available through the API. So it makes it flexible for both workflows, right? So if you want to integrate into a CI/CD pipeline, we provide, excuse me, losing my voice, but we provide client libraries both in like Go and Python, which can allow you to programmatically access or interact with the simulator API endpoint. And so I actually open sourced a project that's written in Go and specifically designed to automate the testing through the WAF simulator. And it includes CI/CD setup through GitHub Actions, and then it runs tests on every code change when it's like pushed to the main branch. And then you can kind of go one step beyond that too. So within Fastly's WAF, there's webhook integrations. And so another step that I added, that anytime there's an event where there's like a rule modified or changed, it will send the event to the webhook. The webhook will then trigger GitHub action workflow to run again, just to ensure that the tests that we've written against the WAF rules are still working as they're expected to. That's just because, if you have shared management of a WAF, you never really know if someone is going to go in there and maybe alter something quickly on the fly, and you want to ensure that you're writing tests to validate that those rules are still working as expected. So if they do alter something, you'll get instant feedback whether or not that detection is going to fail. And if it is, you'll get notified. You'll be able to do active outreach and ping them on Slack or something and ask them why that was changed, or what the process was behind that. So yeah, that's definitely worth checking that out. And if you have questions, we're available. They can always just, even on the GitHub repo, just post, pull a PR or ask some questions there if you want to reach us.
Nice. Yeah, and I did link, this might have been one of the things in the handouts, but I just threw into the chat the link to the detection as code with Fastly's WAF simulator.
It's a tongue twister. Yeah.
Yeah. Fastly WAF. So actually I lied. One more thing before we jump to recommendations here, maybe coming to you, Marcus. One of the things, and I haven't been on the enterprise side in about 12 years now, that the SIM vendors were always selling to us is the power of correlation, right? Like the idea that an event on the WAF happens, and you're going to build some kind of detection that also, Frank clicked a link and downloaded some malware on his laptop at the same time. Like, how realistic is that these days? Are you finding yourself writing a lot of these kind of meta correlation rules? Maybe like a detection on top of detections, like trying to link things together, or is that more something that still just happens in the analyst's mind as they're looking at things and investigating?
I tend to be a pessimist, and so I tend to think that is something that everybody strives to achieve, and it kind of comes in varying forms of, we'll say, success and maturity. I would actually say that maybe Gary is a good point for this one. He might have more experience on that kind of thing.
Okay.
Yeah, I think it's really dependent on the data health, right? When you're writing especially a compound detection, something that's really complex like that, where you're trying to fuse multiple sources, it's definitely possible. You tend to suffer with like readability, having, unless you're commenting your detections. That's another thing. Is like, make sure when you're writing a detection, comment it. Why did I put this clause in here? It's doable, but it really requires strong data hygiene. So make sure that your fields are mapped, that they're compliant to the information model that you're using. So source IP is source IP across all your fields or across all your data sets.
Right.
But I actually think that in a lot of cases, you mentioned, is this something that lives within the analyst's mind? To me, that speaks of an automation opportunity. So in a lot of those kinds of like triage cases, so when we define our detection hypotheses and we write a detection, we always have triage steps. How do I know if this is a true positive or false positive? And these are documents that we have defined. They're actually stored in YAML as code, documentation as code as well. And when we start running through those triage steps, those give us potential automation opportunities. A detection fires, the analyst says, oh, hey, I had to run XYZ step. Then we can take that feedback and say, okay, can we build this into a detection? If not, can we build this into automation? So I think there's two real levers you can pull there. But I think generally see most organizations that, at least that I've worked for and worked with, tend to lean more on the automation side of the house for kind of automating the triage as opposed to trying to write a very complex compound rule.
Yeah, I imagine it's the kind of thing that would become obvious after you. Well, and that's kind of a mindset too. You're like, this is at least the 10th time I've done this before. Maybe it's time to write some code. Maybe it's time to, pull together some queries and automate this a bit, right?
Yeah, absolutely. And I think, again, I just think it comes down to understanding the problem you're trying to solve, and just choosing the best tool for the solution, or for the problem rather. When all you have is a hammer, everything looks like a nail. But hey, I've got a hammer and a screwdriver, so let me figure out what I'm actually dealing with.
Well, that is a good point there. Like, for a lot of my career, there was you kind of had the two sides of it. You had the person be like, all security folks should know how to write code, like even if it's just basic scripting and stuff like that. And then people saying, no, you don't need to know how to write code. You're just gonna, be logging into QRadar and, at most typing queries, right? Learning KQL or something like that. But yeah, now we've got infrastructure as code, policy as code. Code keeps coming up a lot, and yeah, it is kind of amazing that. Yeah, there's some great cheat sheets out there. I really didn't want to mention it, but that is one use case for generative AI that is kind of useful, is writing some of these configs and stuff. I was actually going to say at the end of this, we got through this without mentioning AI, but I just ruined it. So I apologize to the audience and to the panelists for that. But still, given all that, like, what are your takes on security folks having some coding ability in 2025?
I think I can add to that. I think it's important, right? The industry has changed a lot. I think for a long time, everybody knew how to code back, when computers didn't really do much except what you coded it to do. And I think we're in the sweet spot now where you can kind of mix and match. I think it's important to have people that can code, right? You're going to have to build things that talk to other things. But like Gary had said, once you start getting into SOAR and automation, you're not going to really be able to get around it. I don't think everybody has to be a coder, but I think it's important to be able to read code, because you're going to end up reading code at some point. You're going to end up on an incident where you're looking at a GitHub and you're the person that's on call, and it's not your job to fully understand or resolve it, but you're trying to get a gut feel for, what level of incident is this bad. You're not going to get away from code. That doesn't mean that you have to, spend 80% of your time writing Golang or Rust and knowing the latest and greatest trends. But I think it is really important to just at least know that you're going to be in it at some point and accepting that, because it is tech, right? Like, I always say this all the time. Some of the people that do really crazy Excel things in finance, they know way more code than they give themselves credit for, with all these formulas and all these tie-ins and lookup tables. It's everywhere, whether you want
full applications in an Excel spreadsheet. Absolutely. I've seen it.
And even just like, children playing video games, they don't realize that they're coding at some point in a lot of them, or modifying things. I think to kind of just high level answer the question, I think it is important to understand and just be a part of it. I don't think that everybody has to be a coder, though. I think that's a big gatekeeper, and I've definitely been a part of companies that wanted everybody to do that. Even going so far as to change like security titles to like software engineering titles.
Yeah, I think Minecraft alone probably trained, at least 100,000, couple 100,000 developers, right? Being designed for mods from the ground up, and then the people trying to get those mods working. which was always fun. My kids were big into Minecraft, and it's, Dad, set up this server for this adventure map. So now I'm learning. No, not that I didn't know how to code, but picking up skills just to get a game working. Yeah, and so that kind of does bring me into our recommendations, because the first thing I wanted to ask there, I've kind of already asked it, but if you're going to do detection as code, what kind of skills, what do you need to be familiar with there? So it seems clear, like some kind of, comfort level with code repos. You got to store your detection somewhere. You got to do your versioning somewhere, right? So maybe, yeah, go ahead.
I don't think it matters where. I know companies in this day that still use Mercurial and Subversion. Obviously, Git is kind of like the latest and greatest. I don't have a preference. It is what it is. I think it's important. Like I think Gary had said earlier, use what you have available to you. I think it's important not to rock the boat too much. It's more important to adapt and mature whatever process you're trying to mature. But I think it's really about using the tools that are there, being comfortable with them. And I mean, we're talking about detection as code, so just having it somewhere where it's versioned. It doesn't matter where it is, as long as at the end of the day, like I said earlier, that as long as you can retain that context. You want to know why it's there, and you need to know how to change it. If you're not on call and you're the expert, and you're on vacation, you should be on vacation. There shouldn't be somebody ringing your phone because they don't know how to change a detection that is now firing 1,000 times in an hour. And I think it's whatever gets you to that point. It could be manual at some points. It could be fully automated and have tests. But I think it really just starts with, we have to build something, and it has to land somewhere, and it has to have a source of truth.
All right. And just as a reminder to anyone in the audience here, if you have any questions, go ahead and get them in. I've been checking there. It looks like we've got one here. Let me blow this up a little bit so I can read it. What are several misconceptions security teams face when they don't configure or tune implemented WAFs? Misconceptions they face. All right, so I don't know, maybe something like WAFs are just noisy by nature, right? Like I've seen. I guess there's different ways you could take that question, but yeah, Gary, what do you think?
I'm actually gonna. Well, I'll give it my general thoughts. Have to your point of being noisy by nature. Yeah, I mean, when you're looking at something with out of the box rules, it's important to make sure that you can, contextualize the rules that are delivered and available to your own organization. So kind of, I think misconception potentially being like, hey, everything available is perfectly tuned for me, right away. So there's a little bit of work up front to make sure that what you're working on is actually true to your organization. But I will pass this off to Simran, because I think he might have a bit more depth he can apply here.
Yeah, I think just adding to what you said is like what we see a lot too is, at least with that point of view, is customers will look at all the signals, maybe not what's on by default, but what's available to them to turn on for signal intelligence. And it might not be applicable to their environment or their technology stack, but there's like CVE rules for all these different CVEs, and you might be running, I don't know, like a Python-based web server, but you're turning on like a WordPress CVE vulnerability detection. It's like there's no point to turn that on. You're actually incurring like performance penalty by even adding that detection. Like every single detection logic that goes into something, it adds a little bit of overhead. It's very, very small, but like the more you continue to add, the more performance overhead you have too. So it's just like you have to take that into consideration and understand like what you're protecting and what detections are actually applicable to your environment, your application that you're running.
Gotcha. Another good question here. I mean, one of the answers could be this webcast itself, but one of the folks in the audience asks, are there any frameworks or templates available publicly that the panelists would recommend to evangelize or justify using detection as code? anything to help adopt or operationalize the feedback loop process?
I don't have a great answer. I would just say, because I mentioned earlier, I'm a data person. I think the best way to win over, if you're trying to sell this, it's going to come from data, right? You need to justify why you're doing it. And I think it's important. If you can show that you've improved something, then you're going to win. Turning things on or evangelizing something that you can't speak as to what the end goal is never really going to work out, especially if it's a paid tool. And a lot of this, it's going to incur cost in some way. For me, it's always, what problem are we trying to solve and how do I measure that? And I think the measuring is the most important part.
Yeah, I was going to say, some of the, if you look at the handouts there, the security without speed bumps blog post seems like a good one. Some of these posts are more technical than others. Some of them are more in that evangelism side of things. That post has some of that justification in it. And yeah, just maybe this webcast itself, maybe it's tough to get somebody to go listen to an hour-long webcast, but yeah, it's I think that's a tough one. Like I don't think there's any certifications around this, or it's not quite as developed a concept as some of the other things in terms of being able to hand somebody a one pager on why you should do this. But all this as code stuff, I think, is still kind of picking up steam. And I think a lot of people perceive it as something that, those tech companies do, right? But in our industry, like, nobody's doing that. But I'm absolutely seeing it in all industries now.
Yeah, I would also just add, like, just at a very basic requirement, it's like I would say as soon as you're struggling to track changes, or you're surprised that maybe a rule is behaving actually differently than you would expect, you're probably overdue for a detection pipeline, right? So, I mean, if it's just one person, you can really manage it. If you start getting to like two people, then you can consider maybe writing a detection pipeline or doing detection as code. And so then it's just a matter of, if you don't have the skills to do it, I mean, you can still do it in a very basic process, where it's just like linting it, simulating, and then just reviewing. It can drastically help even at that level. So, you can go as extreme as you want or as basic as you want, but any process improvement will greatly help. So, and measuring, indicators as well can help justify for sure.
Yeah, imagine having some support at the leadership level as well. Like I wonder if you have any thoughts on like how high up that has to go, because I have seen cases where somebody's like, okay, yeah, we're going to build this pipeline. They put together everything and then nobody uses it, or they leave the organization and they were the only one using it. So how do you ensure that kind of longevity of the process, like surviving you leaving the company when you're the primary evangelist?
Oh, I think it's
a tough one. It's more of like a layer 8 thing, right?
Yeah, well, don't do anything in a vacuum. Let's just do that. Let's just say that. But also, yeah, you want to get buy-in. You want to get people supporting the idea, right? Like, if you think it's a good idea, you need to go sell the idea to other people to ensure that they're all also going to buy into it too. And I think, like, I remember kind of practicing, the way to get buy-in is you don't just like cast it out, especially if it's like a organizational wide change. You might go work with a specific team and understand like what their requirements are, and understand like, hey, like, if I implement this like pipeline, do you think you'll be able to use it? Do you want to benefit from it? Get their input too, to see how it could help improve that process. And then, once you work with one team, then you can gradually work with another. And then, you can show how the improvements that you're making for both of these engineering teams, and you can continue to roll it out throughout the organization. So that's a good approach too. Start small, understand and refine the process, and then you can expand those principles across the organization if you're working in a large organization.
Yeah. So I imagine, capturing those metrics, like a lot of people in this industry maybe don't see themselves having to put on nice clothes and do a PowerPoint in a conference room, showing how detection as code has saved a whole bunch of time. But, I guess at some points you kind of do have to do that, right, to sell it.
Yeah, it's part of it. Yep. Absolutely. Yeah, I mean, it's you have to measure your success in some way, right? You have to, have KPIs and OKRs and such. So absolutely.
Yeah. All right. Well, that's all we have time for today. Thanks to our sponsor, Fastly, for making today's webcast possible. Thanks again to Gary, Marcus, and Simran for joining us today, enabling us to have this great conversation. Finally, a big thanks to the audience for joining us. We'll see you next time.